Hey everybody, it's been a while since I've done one of these, so let's do this. All right, in case you miss me, I'm down in the corner, but we should be really focused on the mathematics here. Okay, let's evaluate some logs, solve some equations, and then call it a day. How does that sound by you? Me too. Me too. Again, reminder, when we evaluate these logs, okay, remember logs in general, we're searching for exponents. That's a little too thick. Okay, we want to know 9 to the what power is equal to, I don't know why I put 3 there. 9 to the question mark, 9 to the something power is equal to 27. Okay, and what we found out is with these exponential equations, all right, obviously we could use logs. Like I could pick up my calculator and type in log base 9 of 27 and get our answer. But that is obviously not the point. Okay, but what we found out is obviously we found out how to write legibly, and I'll try and do that. So 9 to the something power, I'm just going to call that x for now. Okay, now what we found out is we can turn the 9 and the 27 into common bases. Okay, so we can rewrite 9 as 3 squared, and 27 is 3 cubed. Okay, this is obviously way more work than you'd want for a question number 1, but that's okay. Here we are. Power to a power, remember we multiply those exponents, so 3 to the 2x equals 3 to the 3. And as you know, since we have the same base here, then that means the exponents have to be equal to each other. Okay, divide out the 2, and we do end up getting 1.5, 3 halves, or 1.5 here. Okay, so 3 halves, or 1.5, or 1 and 1 half. Yeah, you know what? No, I'm not doing that. Okay. So that's how we could have done it without a calculator. Number 5, though, since we can see this one right here, this one is much more reasonable. 4 to the something power equals 64. Well, we know 4 squared is 16. That means 4 cubed is equal to 27. Okay, now, for number 9, knowing what we know from number 1, okay, 1/9, okay, which is the reciprocal of the base that we had in number 1, okay, means, all right, so we are taking that, raising it to a power, and getting that. All right. Well, that's very similar to number 1, and as you know, when we do the reciprocal dealing with exponents, that means we have to have some sort of a negative exponent here. So that's got to be negative 3 halves or negative 1.5. All right, let's do a couple of these. All right, number 10. Notice, oh my gosh, there's no base. Remember, it's base 10. That's the common log, which means 10 squared is 100. Obviously, there's other ones here. I'm skipping those. Number 3 should be quick and painless. 4, okay, because 5 to the 4th is equal to 5 to the 4th. We found that out in our investigation. I really wanted to do number 7. 7 and 8 here. Actually, we'll do number 4 as well. Actually, this one's pretty quick and painless. Okay, remember the natural log is base e. E to the something power equals 1. Remember, any number raised to the 0 power is equal to 1. Okay. Now, I wanted to do number 7 because notice, I know to get from 9 to 3, we have to square root it. Okay, but not only that, we took the reciprocal of the square root. So, if you remember, when we square root something, we are raising it to the 1/2 power, and when we reciprocal it, it is got to be a negative power. Okay, and number 8 here, log base e. I don't know why it looks like an exponent. It's not supposed to be. Actually, no, it definitely is. Natural log of e to the square root of 5 is going to equal the square root of 5 for the same reason as number 3. It's the exponent. Okay, and one more before we actually start solving equations here. I know that 6 squared is equal to 36, and I know that the square root of 36 is equal to 6, so 1/2. All right, let's do some equations. Quick reminder, when we're solving, be on the lookout for these extraneous solutions, because we know that when we solve some of these equations, we sometimes get solutions that don't check out. Okay, that is definitely going to happen, especially when we hit some quadratic style equations. Why don't we, let's see, let's do number 16. I have no reason for doing these. I don't even have a calculator open. Okay, so what we're going to do is we're going to focus on exact solutions that you could always obviously plug into a calculator to get the approximate value. All right, I'm going to add 4 to both sides. So we get 7 to the 2x equals 4. Okay, and reminder, when we want to find the unknown exponent value or variables in the exponent, we need to convert that to log form. So log base 7, the thing that's raised to the power, of our argument 4 is going to equal our exponent. Okay, and now divide by 2, so we do get log base 7 of 4, whatever that is, divide that by 2, and that's going to equal x. That is our exact value. Might as well give you the approximate value. Again, log base 7 of 4. Okay, first things first, log base 7 of 4. We're taking 7, raising it to a power, and making it a smaller number, which means that exponent has to be less than 1. And now we're dividing it by 2, so we should get something even less than, so less than a half. Okay, now remember, we can log base, math, log base 7 of 4. I can do this in 2 steps, or I can divide that by 2. And by the way, there you go. I do have this set for 4 decimal points. Okay, we've talked about that in class here. To go at least 3 decimal places, so I just went 4 for consistency purposes. Let's do number 19 since we can see that. Oh, by the way, sorry. Let us actually check. By the way, this is definitely going to work out. Okay, 7 raised to the 2 times 0.3562 minus 1. When I hit enter here, I'm hoping that it equals 3. Okay, and notice it equals 2.9999, which is obviously fine. Since I rounded the exact value in purple, we should expect to see something that's, you know, a good approximation or really close to what it's supposed to equal. All right, we should be able to do this one completely without a calculator because we know stuff. Okay, again, this is log form. Our variable is part of the argument, so if we switch this to exponential form where we've got our base exponent argument, okay, we can say 2 cubed is equal to that unknown value x minus 1, okay, and 2 cubed is 8, which means 9 is equal to our unknown variable. Log base 2 of 9 minus 1, or 8, is equal to 3, of course. That totally works. Okay, and now, quick reminder, if for some reason you are using a calculator from when I was your age, okay, we could use the change of base property, log base 8 divided by log base 2, log of the argument divided by the log of the base, and we can do that as well. Let's just keep going down the line here. Number 22 here is, this one looks interesting. Okay, so let's subtract 2 on both sides. Okay, so we've got 3 times the log base 4 of our unknown value x is going to equal -9. Divide out the negative, divide out the 3, apologies. Okay, and we get log base 4 of x equals -3. All right. I haven't used black in a while here. So that means now, again, exponential form, 4 to the -3rd is going to equal our unknown value x. Okay? And in case you didn't know, 4 to the -3rd is that weird looking decimal right there. But more importantly, it's 4/3 taking the reciprocal. Okay, so 1/64. So that means our unknown value x is 1/64. Okay, so let's definitely go back and plug this in. So we have 3 times the log base 4 of 1/64. Okay, I didn't use fraction mode or anything like that. All right, plus 2, and I am hoping that this thing equals -7, and it does. Beautiful. All right. So that is our way of checking it. You don't have to necessarily write that out or anything. Like if you wanted to, you could just like that. All right, let me crop this a smidge so it doesn't... Oh, look at that one. Let's do that. Let's do whatever number this is. All right, number 25. Okay. Quick reminder, when we are subtracting, we know properties of logs here. So when we are subtracting logs with the same base, okay, remember that we divide the arguments. So we've got the log base 3 of... Okay, and now since our logs and our bases are all equal, okay, we can set the arguments equal to each other. So that means, okay, and as we've done, we got to multiply out the denominator. So we get 2x minus 1 equals 4 times x plus 3. Yes, we have to use our distributive property and all that good stuff. So we get... All right, and I'm going to combine some steps here. I am going to... That did not change colors for me. Many apologies. I am bad at this. All right, so we got that. And I'm going to bring that over there. I'm going to subtract 2x on both sides. I will also subtract 12 on both sides. All right, so we get that, which means our unknown value x is going to equal -13 halves or -6.5. Okay, and again, we just got to go back and make sure that it works out. Okay, so once again, we got our calculator here, log base 3 of 2 times -6.5. Again, the decimal version seems to be quicker, minus the log base 3 of x plus 3, so -6.5 plus 3 equals... Oh no! Darn! We got an error! Oh man, I hope you're ready for that. Okay, again, quick reminder. Now, when we get our negative value here, we should have probably had a conversation at the beginning, okay, where, remember, you can't log a negative number, okay? There's no way we can take 3, raise it to an exponent, and get it to equal a negative value, which means we know in the first log, okay, setting that equal to 0 and solving out, x would have to be 1/2 or more, okay? And in the second one, x would have to be -3 or more. Sorry, more than -3. You can't log 0 either, okay? So x not only has to be greater than -3, okay, to satisfy the middle log. In the first one, x has to be greater than 1/2. So any value less than 1/2, we should have kind of expected this. Okay, so what we did just find out is that all that good work that we did was fine. However, the solution that we got was extraneous. So there are no solutions here. Okay, and again, the -6.5 or the -13 halves was extraneous. Okay, I'm going to scroll down so we can get to, oh, here we go. Perfect, right here. I was kind of hoping for an exponential function. Luckily, we had that conversation at the beginning about 9 being 3 squared and 27 being 3 cubed. Okay, and now that I've got the bases that are equal, we can make the exponents equal. And remember, when we have a power raised to another power, we multiply those exponents together. So kind of set us up here, multiply, solve, and all that. So that's 4x use the distributive property, subtract 3x on both sides, and we find out that x equals 6. Okay. And if you don't believe me, let's slide that over.